My name is Nicholas Hines. I'm a senior mechanical engineering major here at Georgia Tech. I spent my time this semester working in the EMRL lab under Dr. Samuel Graham. I've been working predominantly with graduate student George Pavlidis, and my project this semester is to understand and characterize the residual stress distribution in enhanced gallium nitride high electron mobility transistors, or otherwise known as eGaN HEMTs. So these HEMTs, as they're fabricated, gallium nitride on top of silicon, tensile stresses are introduced in the fabrication process, and I'd like to understand how these tensile stresses affect the device's functionality. I will do this by utilizing Raman spectroscopy to map these stresses across the length of the device. Raman spectroscopy is an optical technique that has the capability of taking very high resolution temperature and stress measurements on the order of 1 micron spatial resolution. Crystal lattice structures like gallium nitride exhibit vibrational modes, otherwise known as phonon frequencies, that we are able to capture and characterize using Raman spectroscopy. And then, using this software, we were able to quantify the changes in peak position and line width of the phonon frequency specific to gallium nitride. Here, as we look at a spectra of one measurement on the device, we quantify the changes in peak position of the E2 high and the A1 low peaks, and in our particular case, we use the changes in peak position of the E2 high peak relative to strain-free gallium nitride to quantify the residual stresses in the device. Having successfully quantified the residual stress in the device, I would like to now power the device and monitor the temperature rise and the thermal stresses incurred in high power operation. And then beyond that, check to see if this high power operation has affected the residual stresses in the device. Beyond that, I've really enjoyed my semester here, and I look forward to working further in my research in spring of 2015. Thank you very much.